All right, hello everyone and welcome to Azure Back to School 2022 and welcome to this session. I hope that you have been enjoying the event so far and I'm really happy that you got time to be a part of this session and to join me here today. So today I will take you on a journey of deploying microservices to Azure Kubernetes Service with Azure DevOps environments and multi-staged Azure pipelines. But before we dig into the topic, I would first of all like to introduce myself and tell you a few words about who I am. So my name is Kristina Devochko and I am currently working as a software architect in a company called Tieto Every. I am really passionate about tech and I try and to learn something new every single day from the tech universe. And I also love giving back and contributing back to the tech community. And I'm doing that by sharing my knowledge and experiences in my tech blog, by volunteering in multiple tech communities, contributing to open source projects. And recently I have also started contributing to tech community by being a speaker. So this is one of my first official sessions where I am a speaker externally. So I'm really excited about this and I hope that you will find this session useful and can pick up some useful information for yourself and your use case as well. And when it comes to tech, I love focusing on cloud native application development with specialization in Microsoft technologies, in Microsoft Azure. And I'm not only looking into how you would make an application cloud ready, but also how you can make it in a secure and sustainable way. I forgot to mention, but I'm based in Oslo in Norway and I love cats, so you are going to see a few cat pictures during the course of this presentation. And lastly, a fun fact about me, I have 3 cats myself and I really love Harry Potter universe, and in my spare time I love going on hikes, puzzling and playing retro games. So if you do not recognize the screenshot from the game you can see on the right bottom of the screen, not to worry. I think that this game was not that popular in its best days, but it really fell into my heart and I'm still playing it when I get some free time. So it's called Kao the Kangaroo and I think that they are developing a makeover of it as we speak, but I prefer to stick to the classics and still prefer the retro version of it, though I haven't tried the new one yet. But enough about me, let's dig into the topic we are gathered for today. So why am I here and why do I want to share with you the information about Azure DevOps environments? If we take a look at current state of things, there are tens or maybe even hundreds of ways you can deploy an application, a microservice to Kubernetes. And I remember back in the day when I, with my team in one of the projects, were looking into the tools that we could use for deployment of our microservices, we were able to combine a list of at least 15-20 tools just on the top of our head that suited our requirements. And you can imagine where you have such an enormous amount of possibilities to choose from, making a choice becomes really hard. And I believe that there is no one tool fits all situation. It really depends on multiple factors and on your specific use case. So that's why I'm here and I would like to present you one alternative way to deploy your applications, your microservices to Kubernetes. And some of the factors that may affect that may influence your choice are, for instance, how many microservices do you have now? How many are you going to have in the long term? Are those microservices stateless? Are they stateful? How complex are the microservices? Though ideally they need to be pretty lightweight and perform a single task. In reality, this may not always be the case, or even if one task is being performed, it may be nevertheless a pretty complex service. So this is an important factor to consider. Another factor is, what are the security requirements in your organization? What does introduction of a new third-party tool mean in terms of cost, in terms of auditing, in terms of approvals, and how much time it will take to adopt such an external tool? Also, you need to take into consideration the resource capacity and the organizational readiness. For instance, who is going to be deploying services to Kubernetes? Do you have a dedicated tech platform team? Are development teams going to own their own microservices, and what their knowledge is? So it's not given that the level of knowledge and competence is on the same high level across teams, and you may not even have dedicated resources maintaining a technical platform. So this really depends on what kind of tool and how you are going to choose, and how complex you are going to set up this whole deployment flow. And there may be also a bunch of other factors, but these are kind of at least the most crucial one you need to take into consideration where you're making this choice. And today I would like to take a look at how we can utilize a tool that the additional functionalities of the tool that you are already using for other purposes in your development lifecycle. And in this case, it's the Azure DevOps tool, and specifically Azure DevOps environments and Azure pipelines. So what are Azure DevOps environments? An Azure DevOps environment is basically a deployment target. It's a location. So an Azure DevOps environment represents a location where you deploy your microservices, your applications to. And as you can see in the screenshot on the right-hand side, this location can be a Kubernetes cluster and not necessarily Azure Kubernetes Service Cluster, an AKS cluster, which we will be using today or looking into today, but this may also be any Kubernetes distribution, for instance, Google Kubernetes Engine, or even an on-premises Kubernetes cluster. And another type of an Azure DevOps environment is virtual machines. So for instance, if you need to deploy your application also to a dedicated VM, then you can create an Azure DevOps environment that will represent that VM as a deployment location. And then Azure DevOps environment represents location overall, but then it also includes a collection of something called resources, and every resource represents an application, a microservice that you are deploying to this Azure DevOps environment. So let's say if you have a bunch of microservices that you will be deploying to AKS cluster A, then your environment will be AKS cluster A, and then you have microservice 1 as resource, first resource, microservice 2 as second resource, and so on and so forth. And then you can easily target both the environment as a whole and specific resources inside of a stage or a job in your pipeline definition. And we will take a look at how it looks like later in the session. So what may be the reasons for why you would want to use Azure DevOps environments for deploying your applications to Kubernetes? And the first reason may be that this gives you an opportunity to utilize the same tool that you're already using for development, and now you can also use it for deployment. As you know, introducing a new tool has its own complications, both from the security perspective, but also from operations, from upgrading, from a knowledge-based perspective, and trying to utilize what you already have to its fullest capacity in case the functionality that already is there in this tool covers your requirements may be quite a reasonable choice in quite a few use cases. Another reason may also be familiar UI. We also need to remember that there are other people who may need to access this information to gather some data, to take a look at what's deployed where, maybe even gather initial information for further debugging in case something goes wrong during deployment. And if you think about developers, they want to minimize the amount of new tools that they need to learn in addition to what they are doing as part of their daily work. For instance, kubectl is a good example of that. It's not given that every backend developer working on developing backend for your application really wants to learn Kubernetes and kubectl and how to interact with those, how to gather logs, and so on and so forth. But when it comes to Azure DevOps, for instance, every developer has been using it. If you have used this tool for a while and they're familiar with the UI, therefore it will not be a huge or a long learning curve if they also need to use Azure DevOps environments, for instance, because the UI is more or less the same and is quite straightforward and user-friendly. And this kind of goes into reason number 3, where you, by accessing this UI, by checking the Azure DevOps environments, the resources deployed into these environments, you get a user-friendly and straightforward way to gather some initial diagnostic that may help you. For instance, to try to figure out what may go wrong in case deployment of an application fails. You can actually go through Azure DevOps UI to the resource you're trying to deploy and gather application logs, check out application logs, check out the overall state of the deployment from there, and check what changes have been done recently, and so on and so forth. So it may give you quite enough information to perform some initial diagnostic. And finally, another reason, which again is about security, by utilizing the tool that you already have, you have established a collection of security controls. You have established role-based access control, which you can reuse when you start using Azure DevOps environments, because then both on the environment level and on the pipeline level, you can configure which individual users, which user groups, which pipelines are allowed to access, to read, to administer, to use different Azure DevOps environments and respective resources. If you were to introduce a new tool, then you need to think, first of all, you need to go through the approval process, and if you are in a large organization, you can imagine that it can take quite a long time, and it's not given. There is no 100% guarantee that the tool will be approved. And then, even if it's approved, you need to think about what kind of security controls are supported and are not supported in the tool, and then you need to ensure that you secure it well, that you isolate it well from public access, for instance, that you continuously protect it, continuously upgrade it, continuously ensure that security fixes, especially security fixes, are being installed. So this requires quite an addition to the daily routines you may already have, and that may not always be the easiest choice for instance, smaller organizations. So this may also be the reason for why you could utilize Azure DevOps environments. So if we briefly take a look at a few functionality highlights that Azure DevOps environments have to offer, first of all, you get to check the deployment history for all the resources that are being deployed in a specific Azure DevOps environment, and from there you can also track which deployments failed, which deployments went through. You can further track the changes that were included in a specific deployment, and you can also check connected work items and commits that have been included in a specific deployment. Also, as I mentioned recently, you can configure access control with user groups and pipeline permissions for who has which permissions in terms of reading and administering Azure DevOps environments and respective resources. You can secure deployments to an Azure DevOps environment with additional environment policies, which are known as approvals and checks, which we'll also see in the demo shortly. You can gather quite a lot of useful information, foundational information that may help you with initial diagnostic in case something goes wrong during deployment of your application to Kubernetes, which may also help your developers that have enough to think about from before. And finally, what you can see in the screenshot below, you can also easily incorporate the deployment environments, Azure DevOps environments, as part of the build of the pipeline execution overview. So as you can see here, for every pipeline execution, you get an environment section from which you can check which deployments happen to which environments and navigate easily further from there. But it's good to talk about it, but what about if we get a bit hands-on with it? So I have prepared an application that I'd love to deploy to my AKS cluster. And it's a pretty lightweight, stateless microservice, so this should be a smooth start for us. So shall we kick it off? I say we shall. So let me just change the scene here so that I can share. Let's see, I don't want to share this, but I want to share my source code with you. So right now we are in my IDE in Visual Studio Code, and here we can take a look at the source code for my lightweight application. This is a .NET 6 web app, which is pretty lightweight, pretty simple, no super complex logic in it, but I am really eager to deploy it, you know. So I have made some preparations in order to spare some time, since we don't want to sit here for ages, right? We want to get the basics fast and furious. So apart from the source code, we can find in the Docker folder my Docker file, which is also very simple for the demo purposes, which will containerize my application. And I also have a Helm chart. And if you're not familiar with Helm chart, not to worry, I will add a resource link where you can, which you can use to get more familiar with it. But what Helm basically is, it's a templating engine. It's a templating tool which helps you standardize the way you are deploying your microservices to Kubernetes clusters across different environments, for example, development, staging, production, pre-production, and so on and so forth. So it's a really, really neat tool when you are using Kubernetes as part of your application ecosystem. So we are going to use Azure DevOps environments to deploy it to an AKS cluster that I got prepared for us. But before we do that, let's just define our baseline and take a look at how the application looks like. So if I just trigger it, start it locally for a second so that we can just familiarize ourselves with an app. So I will start it shortly. Yes, so as I said, I really love cats, so of course if I need to make a demo app, it's gonna be about cats. So this is a very lightweight cat encyclopedia, which I would like every cat enthusiast to access. And when you access it, you get a randomly generated cat fact of the day, and also a cat image of the day. And if you refresh it, you will get a new one. And if you are extra adventurous, you can also spread a bit more love across all the application by clicking on this cozy button here with spreading extra love. So it's very nice, and I really can't wait until it's up and running and publicly accessible for everyone. So let's get it on with. So if we go to my Azure DevOps instance, I have also done some preparations to spare time. So I have already created a repo where the source code has been checked into. Also, to spare some time, we are going to use an existing Azure DevOps environment as part of this demo, but we are going to do some changes so that we deploy a new version of an application to see that things are actually happening. And the reason for that is that it takes a bit of time to expose the application publicly if you're doing it from scratch. So I would like to spare time on that as well. But nevertheless, I will show you now how you would approach this after you have your source code in place in Azure DevOps. So the first thing would be that you need to create an Azure DevOps environment and a respective resource that will represent your application that you are about to deploy. So if we go to pipeline section and locate environment section here, then as you can see, I already have a pre-created Azure DevOps environment, but if I wouldn't have that, we would need to go to new environment, and then we need to provide an environment name. And when it comes to naming strategies and resource grouping strategies, I have a separate blog post on that because there are different opportunities and each and every one of them have their pros and cons. So I will link it in the end of the presentation and you can check it out for yourself. But the way I prefer to name it is first I would like to provide the Kubernetes distribution that this environment is going to represent, and in my case it's AKS. Also, if we check in the portal, in Azure portal, I have two clusters that are deployed. And I would like to use the one called AKS 1232. So typically the second parameter I would provide as part of the name is a unique identifier for the AKS cluster I'm going to deploy to, and in this case it's 1232, which is an ID, so I would use -1232. And finally I would like to use an environment type, which the location will be representing, and in my case it's dev. Also, you can add some description which can make it easier for external other resources accessing Azure DevOps environments to understand what this specific environment represents. So you could add description like this ADO environment represents AKS 1232 cluster for development workloads. Something like this. And then you need to choose a resource type that this environment will be representing. And in our case, it is Kubernetes. And once we click next, what will happen is that Azure DevOps will connect to Azure and try to retrieve available subscriptions. And once you choose a subscription, it will retrieve available clusters for you. So as I said, we have two clusters. I'm going to use the one with ID 1232. And then you can either use an existing namespace. In my case, application was pre-provisioned for the demo purposes, but when you are deploying for the first time, you may not have the namespace in place, and then you would need to choose new and provide the namespace that your application will be using. This will also be the name of the resource. So if I didn't have it in the existing, if I didn't have my application's namespace in the existing category, I would use cat encyclopedia 2, but it would be cat encyclopedia here. And once I click validate and create, what will happen then is that Azure DevOps will create this namespace in the AKS cluster itself for me. It will also provision a service connection for this application that will allow Azure DevOps to deploy new versions of application to the respective Kubernetes cluster. So you would then click validate and create, and the environment will pop up here like this. And if we go into it, we may also see that the resource that we have provided, the namespace that we have chosen, would also generate the first resource for us as part of this new Azure DevOps environment. So if we also take a look at service connection, this is also an important point in terms of security. If we go to service connections here, we can see that a service connection for my AKS cluster 1232 and cat encyclopedia resource, cat encyclopedia namespace was provisioned. Apart from that, what will be provisioned, not only the namespace will be created as part of the AKS cluster, but a specific service account for Azure DevOps with a specific role binding limited only to the namespace of you have chosen will be created in your cluster. So I would like to show you that as well. So I will open my terminal and use some kubectl commands. And as I said, of course, for you who would be configuring this, it's good that you are familiar with kubectl and generally deploying and operating applications on Kubernetes. But for your developers, as we will see as we'll see shortly, they would not necessarily even need to know or use kubectl to perform initial information gathering and monitoring. But we're going to use kubectl as part of this demo. So let's check that I have the correct cluster as active in my kubeconfig in my current context. So I'm going to use kubectl config current context, and it's 1232, so it's correct. So first, let's take a look at the service accounts that have been provisioned as part of the cat encyclopedia namespace, which is the namespace of my application. So kubectl get sa minus sa for service account minus n for namespace encyclopedia. As you can see, there are a few default accounts that are being provisioned for us when an application is deployed to Kubernetes cluster, but this one, we can see as dev, it signals that this is a service account connected to Azure DevOps and provisioned by Azure on behalf of Azure DevOps. So if we take a look now at the role bindings, if you are familiar with Kubernetes definitions, the difference between cluster role and role is that cluster role typically can be non-namespaced, so it may, if it's assigned to an account, it may have permissions that this account can use across cluster as a whole. But if you use role and role binding, then you are giving a specific service account a role with permissions that are limited only to the namespace. So role is a namespaced object, it's a namespaced resource. So if we take a look at role bindings in cat encyclopedia namespace, we can see that Azure DevOps role binding has been created for Azure DevOps service account 11B373, which we can see here, admin on cat encyclopedia. And it is the cluster admin role, which has quite extensive administrator permissions that this service account can use, but only in cat encyclopedia namespace. So which means that this service account will not be able to do any operations that cluster admin role allows on any other namespace than the one you have chosen and the one that has been provisioned by Azure DevOps for you. So this is the way you isolate all the different resources and restrict the permissions for deployment only to that specific resource and its specific namespace, which I see as a beneficial functionality in Azure DevOps environments. Another important thing I would like to mention, since we have been talking about naming conventions and grouping strategies and all, I would like to illustrate what may happen if you choose to group resources differently. What comes by default as the part of Azure DevOps environment functionality is that even though I have created an Azure DevOps environment for a specific resource, which I signaled about in the Azure DevOps environment name, I can still go and add a resource that targets a different cluster. I can still do that, it's allowed, but the trick here is if I attempt to create a resource with the same namespace, targeting the same namespace that the existing resource targets. Even though this new resource will be using a new AKS cluster, a namespace conflict will actually happen. So as you remember, I have shown you that I have two clusters here. So let's attempt to create a resource with cat encyclopedia namespace, which will target another cluster, 1233. So here I have clicked on the add resource, and here I will be choosing Kubernetes resource. Now once again it will try to provision to retrieve subscriptions and clusters for me. So this time I'm going to choose cluster 1233, and in existing namespace we don't have cat encyclopedia, so let's try and create one. Cat encyclopedia. So as you can see, this is the same namespace as the existing cat encyclopedia has, though that one is targeting cluster 1232. But if I attempt to validate and create this new resource, I will actually get come on. There you go. I will actually get an error message saying that it failed to create a resource because resource with this name already exists in current environment. So therefore, when what I can recommend when it comes to grouping your resources, grouping your Azure DevOps environments, I would recommend to only let an Azure DevOps environment represent a single location. It will also make your deployment overview more structured, and it will make it easier for others when they come in and need to check something, do something with Azure DevOps environments or respective resources. It will make it easier for them to find what needs to be found, because then they know that this environment targets this cluster and this environment targets this cluster and so on. And then you would also avoid, as a benefit, namespace conflicts like this one. All right, so we've got that in place. Now, since we already have an instance of an application running in AKS cluster, we should make some changes to this application and deploy a new version so that we can actually see that things are happening. So let's get back to the source code. What I recently found out is that, oh my, I have forgot, by accident or not, for this demo I forgot to add health probes. And that's not good, because if you are deploying an application to Kubernetes, you would really want to have some health probes available to ensure that once your application is marked as active and once requests start hitting your app, it is actually healthy and able to respond. So I have, by accident, of course, commented out the health probes. I have a liveness probe, which Kubernetes will use to identify if the pods are up and running, if the application containers are up and running, and everything looks good, and the application is available and up and running in the cluster. And readiness probe will ensure that the application is able to respond to the requests coming into it. So I have a specific endpoint that I have configured as part of my cat app, which I will be using for these probes to target during deployment stage. So let's comment those out. And another thing that we will need to do is that once this has been commented out, we also need to let our build pipeline know where it will need to deploy our application. So when you are doing this from scratch, of course, you will create your pipeline from scratch, but again, I have prepared this for the demo purposes, and what we can see here is my build pipeline definition. And that's where you can see that my pipeline is multi-staged, and it's a really useful functionality that you can utilize in order to gather all the stages of your application lifecycle from development to testing to deployment in one pipeline. So typically you would have multiple stages, one for building, one for deploying to dev, one for deploying to staging, to production, and so on. And in every stage you may have multiple jobs that can be run in parallel. For instance, you can have one job for building an app, one job for running automatic tests, one for running security checks, and they will be run in parallel as part of your build stage. So that way you will ensure that your application is of high quality before it even reaches any environment. But since we are running a very lightweight demo, I have only 2 stages with a single job per stage. So here you may see the build stage with a build and package job. This job will build my .NET web app, publish it, build and push a generated Docker image to my Docker Hub repo. It will package my application as a Helm chart and also publish it as an artifact that will be consumed by the deployment stage. And here is my deployment stage, and you can see that there is a neat property here called depends on. And this property means that deployment stage cannot run until build stage has succeeded, which makes kind of sense. And what another interesting thing we can see here is that in the jobs section I am using a specific jobs type, which you will also need to use if you're going to deploy to Azure DevOps environments, and it's called deployment. So if we take a look back at the build stage, we can see that here we have used a regular job type called job. But since we're deploying to Azure DevOps environments, we will be using a job type called deployment. And by using that, we get an opportunity to target a specific Azure DevOps environment and a specific resource by defining a property called environment. So here, obviously, we will provide the name of the Azure DevOps environment we're targeting and the name of the resource we're targeting. So if we go back to our Azure DevOps environments page, we can see that our environment name is AKS1232 dev, so we will add it here. We will also add a dot to separate that now comes the resource name, and the resource name is cat encyclopedia. So let's add that one as well. Good. Now, by doing that, we have told our build pipeline, hey, you need to deploy whatever comes next in the build tasks. You need to execute it towards Azure DevOps environment 1232 dev and towards cat encyclopedia namespace and resource. And what happens here is that it will basically install Helm and deploy the Helm chart to our resource to cat encyclopedia namespace. Here I also have a commented out build task for your reference. If you're using private Azure Container Registry, for instance, or any private registry, you might need to have additional build tasks to provision a private container registry secret, which will actually allow you to push and pull container images to your cluster as part of the deployment process. Alright, so I think now we are actually good to go. So let's just verify our changes. So this one looks good and this one looks good. So let's commit them to our source. No, actually, one more thing we also need to do is that we need to let the pipeline know that this will be a new version of the app. So let's change it from 102 to 103. Now we are good to go. So add health probes, update version, app version. So now we are good to go. And I think that I will actually do it through the terminal because I need to paste git push origin main, and I will need to provide a password here. Just give me a sec. Let's see. All right. Now we have committed our changes, so let's get back to our repos. And as we can see here, just now we have recently added our changes to Azure DevOps, so we are ready to deploy the new version of the app. So if we go back to our Kubernetes cluster, we can also just give it a quick look, kubectl get pods, namespace, cat encyclopedia, so that we can see that the app is up and running, 64 minutes. So let's deploy a new version of the app by going to our build pipeline and running that. So here you can see now that we have started a new pipeline execution. It has generated the two stages for us, the one for the build stage and the one for the deployment, just as we have seen in the pipeline definition. And if we expand here, we can also see that here you may have multiple jobs that will be running in parallel, that will be doing running automatic tests, doing security checks, building an app. And then you may have subsequent stages as well that will deploy your application to staging and to production and so on. So while it's building, it should not take a lot of time. It will take a minute or so. But while it's happening, I would like to share quite a neat tip with you, which comes to exposing your application for public access during tests and prototyping. So when you typically create a new AKS cluster, you also need to ensure that you create and configure an ingress controller, which actually is a resource that will route all the requests to proper applications depending on how you have configured your ingress objects. And you also need to provision some kind of a certificate management service like Cert Manager, and you need to ensure that you have a DNS zone in place and DNS entries in place for every new application you want to expose publicly. And this may gotta be a lot of work. For instance, if you need to prototype something or test something, maybe even as part of your own demo or your own local development. So in this case, AKS can make it so much easier with the add-on that is available to install both for new AKS clusters and for the existing ones, and it's called HTTP application routing. So if we, for instance, go to this AKS cluster here in my Azure portal and take a look at the properties down here, we may see that I have HTTP application routing enabled. And what this add-on basically does is that it provisions an ingress controller for us automatically, and it provisions a DNS zone that is custom generated just for this specific cluster. And based on the specific annotation, which I'll show you shortly, on an ingress of your application deployment, it will automatically add a DNS entry to this DNS zone for you, which basically lets you skip all the process with setting up ingress controller, with setting up certificate management system, and so on and so forth. So if we also take a quick look into the DNS zones in my portal as well, you can see that 2 zones have been provisioned for every respective AKS cluster for me. So A6EB, if we go back to our app really quickly here, I can also show you in values of my Helm chart, the ingress object is enabled because that's the one you need to enable to expose your application publicly. And you can take a look at the annotation here. It's called ingress class add-on HTTP application routing. That's the annotation that will let Kubernetes cluster know, hey, I need to create a DNS entry for this one. I need to expose this application publicly. And once you have added that, you will just need to ensure that you also add a host here which your application can be accessed by. And it will represent the name of your app, which is the same as the namespace here, cat encyclopedia, followed by the DNS zone name that we have just seen here. And once that's done, then your application is publicly available. And it takes some time to make it available when you first provision it. That's why I haven't done it from scratch as part of this demo. But it shouldn't take that long when you do it as well. So give it a shot when you get a chance. So as we can see, then the build and deployment stage went through and our app is accessible in this awesome URL. So let's try to access it and see that it actually works. Woohoo! Take a look at this nice cat encyclopedia. I'm so proud of it. Finally, it's up and running in my AKS cluster. And I can also see that I get new pics here as well and new facts, and I can spread all the cat love I have to give here all day long, along with thousands of users that will be accessing my application once it goes viral. Alright, so it's up and running with Azure DevOps environments. That's awesome. So if we give it a quick check here in kubectl get pods, we can also see that our app has been running for 3 minutes, which means that the new version has been provisioned. Success. Now, what information do we actually get if we go and take a look at Azure DevOps environments? Let's start with the environment level first. So when you take a look at the environments page, you can filter on the environments which have the latest deployment which was succeeded and the latest deployment which failed. You can also search for an environment in case you have hundreds, and you can also configure security, and that's what I was also previously talking about. On the environment page level, you can configure which user groups are allowed to access the environments page in Azure DevOps and are allowed to create Azure DevOps environments and are allowed to use or read information about Azure DevOps environments. So it allows you to have some kind of granularity in terms of access control on the environment level. So here we get an overview of all the different locations that we deploy to. One thing I also forgot to mention, if we take a look at the pipelines here and get back to the latest execution, if we open this one, we can also see, just like the screenshot you have seen on the slide earlier, a new section popped up here called environments, from which we can actually see all the environments that this build pipeline deploys to. So if you have like deployment stage for staging, for production, they will also pop up here, and you can from here navigate further to a specific, oh sorry, this will just take you to the stage. This will take you to a specific deployment, to a specific build job, but you can also navigate to Azure DevOps environment from here, which is where we'll end next. So now, when we go into a specific Azure DevOps environment, here we can get a bunch of resources which will represent different applications that are currently running in the respective AKS cluster. So here I have only cat encyclopedia running as of now. You can also filter, in case you are mixing resource types, you can filter which resource type you want to look at and the status. If you can filter based on the failed, on the resources which have latest failed or succeeded state. Now, if we take a look on the security on an individual environment level, we can click on the three dots here and find security. And here we can also define which users and user groups are allowed to see this environment, access it, use this environment, and administer this environment by creating and deleting resources. And yes, this also allows you to configure it on an individual environment level. And you also see a new section here, or an additional section here called pipeline permissions. And this one defines which pipelines are allowed to access and use this Azure DevOps environment and resources in this Azure DevOps environment. And currently you see there are no restrictions, so any pipeline may use this resource, so we might not want to allow that, so we can restrict permission. For instance, since I have only one pipeline, I can just do like this and it will be automatically added to me. But if there are more pipelines that you would like to add, you can do that by clicking on the plus here, but since I have only a single pipeline, there are no more pipelines to add. So now this pipeline is officially allowed to use this Azure DevOps environment, and if I create a new build pipeline at a later point to deploy a new microservice, a new application, I would need to ensure that it's also allowed to use this environment. I don't need to go back and add it explicitly here. Once the deployment stage for that new pipeline will execute, it will first ask me about providing permission before doing the deployment, so that I can provide permission directly from the build pipeline itself. So now if we go back to the resource overview and go to the deployments history, here we may see the deployment history of all the deployments that happened for different resources in this Azure DevOps environment. So if I have multiple applications running as part of this environment, I will get more entries for different apps. So I can also go into the filtering and filter just on a specific resource, on a specific application. But since I have a single one, I get to see only that. And by accessing an entry of those, I can see when the job was executed, which changes are connected to it. So which commits are included into this deployment and which work items are connected to that. So if I have connected any work item when I added changes, latest changes, which you would typically do in a production setup, they will also pop up here. And then if we go back to the resources, before we access a specific resource, one more thing I want to show you is that you can also edit the name and the description if you want to. And the approvals and checks, which we will take a look at shortly, are also available here to define even more granular control or validations that need to be done before the deployment is executed. So there are quite a few available there, but we'll take a look at it in a moment. So let's go into the resource itself. So this is the page that represents my cat encyclopedia application. It's a state in the AKS cluster as we speak. So here we can get a workloads overview, which means that this page represents my deployment, but it also can represent a few other resource types. So if you are running, for instance, daemon sets or stateful sets as part of the same resource, part of the same namespace, they will also pop up here. But I'm running a deployment, so that's what we can see here. And it can provide some information about how the application is deployed and managed. So we can see it's managed by Helm, so it's a Helm chart, what the version of the application is and what is the version of the Helm chart, and it may differ in real life scenarios. So if we can also see the amount of pods that are being provisioned as part of the deployment and state of those. So if, for instance, one of them fails or all of them fail, you will also get to see this green change into red, which we which we really fear. So let's go into this deployment. And here we can see a bit more information, also information about the Docker image and its version, the tag that the application is being deployed with. We can see pods, so if there are multiple pods, they will pop up here, and the status of those pods. So if we access that one, we can also get some more information like pod details, what the restart policy is, what the current status is, and what are the conditions that identify this pod as healthy. We can also go to the YAML stage, and here we get an overview of the pod resource definition, which you would typically do by doing a describe kubectl describe pod with kubectl, but this you get just here in the same Azure DevOps UI. And then you can get some information about for instance, resource and request limits, if there are any volume mounts, if there are any probes configured, which we have recently did, so good job. We can see them here. What the image pool policy is, the restart policy, any tolerations, and the status and the history of that. So you can get some information for every pod running as part of the deployment. And finally, in order to retrieve the application logs, which may really come in handy, which we'll see shortly, you can go to the logs tab here, and you can see all the logs that the application provides. And this is not streaming live as we speak, so you need to make a refresh to get the latest logs. Yeah, so if we go back to the workload overview, you can see that there is a separate tab here as well, which says services. And this tab also represents the services that are also deployed as part of the same namespace, the same application, the same workload. So you may also filter here in case you're using different service types. You can also filter based on the service type. And here we can see that this cluster IP service exposes the pods running in my deployment, this cluster IP with following port with no external IP. And then we could go to that service and get some more information about the service itself, about its session affinity, for instance, and we can also see which pods this service exposes. So if you have multiple pods, they will pop up here as well. And from here, you can navigate both to the workload itself and to an individual pod. So far so good. Now we've walked through all the different sections that you may need to work with when you are utilizing Azure DevOps environments. So what do you say if we make some damage? Let's see what happens if someone does something and adds some changes which will cause our application deployment to fail. Ooh, exciting. Let's do that. So I have created a separate endpoint that is available as part of my app. By the way, I forgot to show you that the OK endpoint that our application or that the AKS cluster used to identify if our app is healthy or not was called OK. And I'm really proud of that one because it gives you a really fabulous OK message saying it's really OK, our application is cat OK. But I have also a separate endpoint that actually will make our application fail. And that one is called bad health. And obviously, it's all in the naming. It really gives us some bad health. So it just says that it's unhealthy and it returns a bad HTTP or bad request error. So that's the one we're going to use to kind of simulate a failing application. So let's get back to our source code. And now, in order to do that, we will need to go once again to our deployment YAML and update our health probes to use a bad health endpoint instead of OK endpoint. So let's do just that. and also let's update the version of an app. So we are ready to go. So now we can say updated to simulate bad health. So we are doing that, and then I need to push it again and to provide shall we see, and to provide a password here. Alright, now we have checked that in, so let's check that the changes appeared here. They did. So let's trigger a new pipeline run. And see what will happen. Of course, things may go wrong. And now we will be able to see how, for instance, if something goes wrong and the product manager gets back and says why the new version isn't deployed, goes to a developer, and then the developer is really stressed and does not understand where he or she needs to go and gather some initial information, and then they would typically go maybe to the operations or to the tech platform team. And this functionality that Azure DevOps has to offer can actually make this job a bit easier, and maybe can boost the development teams to take more ownership of those microservices, that those applications they are developing. And this is kind of what you want to have in an ideal situation where you have a distributed system, where you have microservices running. You would want your development teams taking full ownership from design to development to deployment of an application that they own. But in order to do that, they also you need to help them, and we need to help them. We need to help our developers to kind of minimize the learning curve and minimize the amount of tools they really must know of and must use, and especially if they are not going to use it on a daily basis, it becomes really hard to stay motivated and kind of not stress out in such a situation. So now we are getting close to the deployment, and while it's trying to deploy, we have a 5 minutes timeout, so it will run for a while, but we can go here back to our command line and check get pods. You know what, I'm not gonna type this, I'm just gonna do like a lazy developer. Alright, we can actually watch live, so let's watch how it's going here. Oh no, here you go. You see that the application started going into a restart mode. Well, that's not good. So something's not right. What do you think? So while it's doing that, let's take a look. So it has been running for almost a minute already, and it's never a good sign, especially if you have a very lightweight service like I do, a very lightweight application. So let's go back to Azure DevOps environments and see if we can get some information already now of what's happening with this deployment. So what we do here is that it's still running, since it needs 5 minutes to actually time out and fail the deployment stage, but we can already now go and check what's happening. And here we have an illustration of an amazing thing that Kubernetes and Helm has to offer for us, which is a rolling upgrade strategy. And what this basically means, if you're not familiar with that, is that if you have a healthy version of an application up and running in any environment, but especially in production, it has a lot to say. Once you decide to perform an upgrade and deploy a new version of your app, in case it's unhealthy, in case something goes wrong through the deployment, Kubernetes does not kill the healthy version of an app and Helm kind of has it baked in as part of its functionality. And if you're using Kubernetes deployment templates, which are YAML manifests, you would typically have like a upgrade strategy defined there. But in the rolling upgrade, if it's defined as an upgrade strategy, the current healthy version of an application will still be running until the new version is marked as healthy. And once it is marked as healthy, the old application can be, the pods running older version of an application can be terminated. So though it fails on version 104, 103 is still available, so we can still access our application and avoid the downtime situation. So this is the zero downtime way to upgrade your applications. So let's take a look here. Oh, now it has restarted for 4 times and went into a crash loop back off. So this is not good. So let's try to figure out what's happening here. Of course, we know, spoiler alert, we know what the reason is, but if you were a developer, you could actually be able to gather some info to see, okay, this new version fails, let's access this workload, let's access this failing pod, and see, oh no, it says that the container is with unready status, so the application is not up and running, is not ready. But the pod was scheduled successfully. So in this case, I would attempt to go to the application logs and see if I may find some information there. And oh my, I can actually find some information there. So the application logged that something terrible happened. So cats cannot be loaded. You need to check your health probes. And this is a very descriptive and informative message for me. So I know that something is wrong with the health probes. So I can go back to my workload. Actually, I can go back to the Azure DevOps environments here and go to the deployment history and take a look at the latest deployment. Now let's see, 5 minutes. Yeah, it's getting close to that. So maybe we will just let it fail in 4, 3, 2, 1. 5 minutes. There you go. So now it failed on the timeout because we have configured 5 minutes timeout condition. We can actually see it here on the Helm deploy. We have configured it to be 5 minutes. So it has timed out. So if we go back to the Azure DevOps environment, we can actually see that the latest deployment has failed. And we can see it here as well. So if we go to the deployment history, we can see that the latest deployment failed, and we can access that one and take a look at what have been the recent changes that happened here. So we can then access the latest commits and see what happened here. And oh my, this was a change that was never supposed to see the world. So let's fix it. But before we do that, we also want to introduce some additional checks to ensure that this doesn't happen again. So let's do that first. If we go back to our environments and access the Azure DevOps environment that we are targeting, let's go to the approvals and checks and add some additional controls that may help us to have more controlled deployments. There are a lot of checks here. I am trying to rotate them, but for today's session, I'm going to show you the first 2 checks that we will configure together. So the first one is approvals, and this is the check that defines that this group, user groups, or this individual users need to approve this deployment before it can be executed. Since I am all by myself in this Azure DevOps instance, I would just use myself as an approver, but in your case it will be a specific user group representing the owners of the different resources deployed in this environment. And here you may provide some instructions to approvers, the kind of a checklist that may help them to when they're reviewing the new deployment. So for instance, chance that health probes are legit. And then if you go to the advanced section, you would typically not allow approvers to approve their own runs. Just like in the pull request review, you would like someone else, another pair of eyes, to take a look at it before it's deployed, but I will need to choose it since I'm all by myself in this Azure DevOps instance. And then I'll configure a timeout of 1 day. So if no one has reviewed and approved or rejected this deployment, it will just time out in 1 day. So let's create that one. And another check we want to create is the branch control check. And in this case, we would like to define the branches which we are allowed to deploy from to this Azure DevOps environment. So for dev, you might not need to configure this because you may want to deploy also from dev branches, but for production, for instance, you would want to deploy from main and main only. So this would be a good check for you to have in place for instance, a production Azure DevOps environment. But we will do this just for the demo purposes here. You will need to provide a full branch name, so it will be refs, heads, main in this case. You may also want to choose to verify branch protection, which means that this check also validates that the branches that are whitelisted they have the proper branch policies in place, where pull requests are enforced, where successful build is enforced as part of the branch policies. So I will not be choosing that one because we are in the demo mode. And timeout that you may configure for this validation. Alright, so we have added some additional checks that may help us to have a more granular deployment. So while we will be fixing our changes, let me illustrate how the branch control policy will be enforced. So I have a dev branch here, a test branch that I have created, which has some additional changes that I don't necessarily want to check in, like some updates to README file. So let's attempt to deploy, to run a build that will deploy the changes from this dev branch to the respective Azure DevOps environment. So I'm going to choose this branch when I try to execute a new pipeline run. And while it's up and running, we'll get back to main, to our main branch, which in our case we are using for adding changes, and try to fix what went wrong. And then we would need to go back to the deployment YAML and fix those endpoints to the proper ones, health endpoints to the proper ones. So let's get back to the proper health endpoint here and commit our changes. Updated health probes to the valid ones. And let's also link a work item. I have actually one important user story that needs to be connected to these changes. So let's commit. Good. Actually, now we will also need to update the version to say that, hey, now we want to have a legit version of our app running. Updated app version as well. So let's do that. Commit. Alright, let's get back to our deployment from the dev branch, and as we can see here, 1 out of 2 checks failed. Also the other approval check also kicked in, where I actually need to review that this deployment looks okay. So I review it and I see that the other check actually failed as well. And if we go to that one, we can see that the allowed branches are defined as refs heads main, but the one I'm trying to use is actually refs heads test branch, and this is the reason for why the check evaluation failed. So of course, after I have seen this, I will definitely reject and say no, I don't want it to happen, this deployment. So let's try to run a new pipeline now that we have added our changes and fixed our health endpoint, identified the root cause and added a fix, and now we are ready to deploy a new version of an app. So let's trigger that one towards main branch. And there is one tricky thing here, is that Helm kind of gets a bit moody when you have when you have a should see Helm history, and you have one pending upgrade that is kind of failing. So let's take a look at the Helm history. I always forget this cat encyclopedia release name. So here you can see there is a failed upgrade. So let's remove that one by doing Helm rollback, get encyclopedia. Let's use revision 9, which is the one that is currently running. And we will do that so that Helm cleans up the pods that are in a crash loop backoff. So let's do this. So it has been rolled back. So if we take a look at the, we can actually watch what will happen right now. So what we can see is that we still have the initial healthy, pre-bad health change version of an app running. So now our checks have kicked in, and now we can see that if we take a look at the branch control check, it passed because we are actually using the whitelisted branch to deploy. So now everything looks good, and we can click OK, or we can approve the deployment stage. So let's get back and just sit down, take a bit of a popcorn and watch how the rolling upgrade kicks in here. Now I think it should be happening in a GIF. There you go. So it attempts to create a new version of our app. Trying to verify that those health probes are good. And now that it has done that the pods are marked as healthy, the deployment is marked as healthy, it terminates the previous version of an app which was running. So if we do this again without watch, we can see that we have a new version of app up and running in our AKS cluster. And if we can see here, the build has passed as well, and we will refresh our application. Well, that was a strange cat image of the day. Nevertheless, so it's still up and running and working and spreading cat love to the whole world. So very, very good. Now we have gone through also a failure situation, which is really nice. And if we take a quick look once again into our Azure DevOps environments, it looks good. Everything has passed, and we can go and see that the version 105 is now up and running. So the last, I think we have been through the most important pieces, and the one piece remaining is the migration of resources to a new Azure DevOps environment. So there may be situations where you may need to migrate the resources that are targeting a specific Azure DevOps environment to a new one. And one of the reasons may be, for instance, your cluster upgrade strategy. So if you are using an out-of-place upgrade strategy for your AKS clusters, where you create a new AKS cluster targeting a newer version of Kubernetes, and you create that one, and then you migrate all the workloads, all the microservices running in the current AKS cluster to this new AKS cluster targeting the newer Kubernetes version, then you will need also to migrate your deployment targets to a new Azure DevOps environment. And the way you may do that is that you will need to go to Azure DevOps UI, click New Environment, and create every single resource manually. And this requires a lot of clicks and a lot of manual work, which is kind of not something you would want to do, especially if you have tens of resources. So you can actually automate this to some extent, and Azure DevOps provides a REST API that we can use for that purpose. So I have created, for instance, a PowerShell script that helps me doing that, which I will also share a link with you for, that you can also customize to your use case or just use as a foundation for your own automation for this purpose. And one important note to mention on that is that, of course, if you have stateless microservices, that's really easy to do that, because you just run a script like that, you perform the migration, and then you just update your deployment stages to target this new Azure DevOps environment. But if you have stateful microservices which are using, for instance, databases or need to preserve state, there you may need to take this automation to a bit further level and have some further automation in place for like doing the necessary preparations for the migration, to performing some backups before you actually do change the Azure DevOps environment that you're targeting in your build pipeline, so that you're just aware of that. So let me show you this this script I have been talking about. As we have seen, I have two AKS clusters running, and let's say I would like to migrate my resources in AKS 1232 to AKS 1233, and I'm lazy, I don't want to be doing all this unnecessary clicks. I just want something to do some magic and create this for me. So for that I will need to open my GitHub repo where I have this script available. Let's take a look here. I have this this partial script, so I will add a link, as I said, to it so you can familiarize yourself with it. It requires quite some information from you so that it is actually able and has permissions to do changes in Azure DevOps and retrieve some information about the AKS cluster you're targeting. But I have a cheat sheet here which I will use in this case to just demonstrate how this would work in practice. So let me just navigate to the proper destination here and then paste this. So what will happen is that I provided the personal access token. Don't use that one, it will be removed by the time we are done with the demo, but you would need to provide a personal access token for Azure DevOps, the Azure DevOps URL to your project, the environment you are migrating from, which in this case is 1232, and the Azure DevOps environment you are migrating to, which will be created for you if it does not exist from before. Also, you need to provide the name of the AKS cluster you're targeting, the way it is defined in Azure portal, the way it is defined when you created an AKS cluster, and also some information from Azure portal, like the resource group where the AKS cluster is deployed, Azure subscription it's using, and then the ID of Azure AD tenant ID. So once it's in place, let's just run it. So it will first just for sanity check log me into Azure so that I will have the necessary permissions to, so that the script will have necessary permissions to perform the operation. And once it's done, it's done. Success. All resources have been migrated to AKS 1233 dev. So let's get back to our UI and refresh it. And here we may see that a new Azure DevOps environment has been created for us, and all the resources that I had in the previous environment are actually here. And they have never been deployed, which kind of makes sense because we haven't targeted or executed a deployment stage for them yet. And the next step you will need to do after that's done is to upgrade your pipeline definition. And if you have multiple targets, multiple deployment stages, going into one and every one of them and updating the environment property manually is kind of a lot of hassle. So another recommendation I may come up with in this case as well is, instead of hard coding the Azure DevOps environment like this in every single pipeline and every single deployment stage, I would recommend you to create a variable group or use a variable group you might have from before and just add some additional variables to it. So in this case, I will create a new variable group, which is ADO environments. And then I will add a description which will tell others what this variable group is. So this group contains all active ADO environments. And then I will add ADO env dev variable, which will represent the Azure DevOps environment for development. And let's use the existing one, AKS 1232 dev, the one where our application is currently running, and save. And then we can update our pipeline definition by integrating this variable group in here, so ADO environments. And instead of hard coding the name of the environment here, we can now refer this ADO env dev environment like this. Also it's important to integrate it, to extract it here in the root level so that it can be compiled, that the value can be retrieved and populated at the build definition compilation stage. Otherwise, it will create some failures if you don't do that. So let's just commit it. Change to ADO var group. ADO env var group. So now we can just do the last run just to see that it is still able to use this variable, to use this variable group here. So now we are rounding up this today's demo, and please take your time, pause this session and try to go through all the stages yourself with your own demo application. You can also use my demo application if you would like to test it out as well. You are very much welcome to do that, and only by doing step-by-step walkthrough yourself you will get some hands-on and even better and deeper understanding of how this works. But I hope that this can make it easier for you to start using Azure DevOps environments, and I hope it was useful, and that you can take some of the considerations, some of the reasoning into your own decision-making process when you're planning to choose a deployment tool for your applications and for your microservices. So I can say, at least from my own experience, that we have started with using a totally different external tool first for deployment of our microservices, and after some time that we have realized that it was good in theory, it was good in the beginning, and then it kind of didn't work that well for us and for our needs. So we have decided to utilize what we already had, to utilize the additional functionality in Azure DevOps with Azure DevOps environments. We have been using it for a while now, and it has worked pretty well for us and for our use case, and maybe it will for you as well. So I hope this has helped. So as we can see, the deployment stage has passed as well, which means that it is able to use the variable from the variable group. And then what makes it really easy is that it minimizes the amount of manual changes you need to do. Instead of going into every single build pipeline definition, you can just go and update it once in the variable group for your specific variable. So it makes this process less cumbersome. All right, I think we are done with our demo. I hope you liked it and had as much fun as I did. So let me just get back for a few seconds to my presentation mode. Oops, and let me just change the scene here. All right, so to sum it up, what may be the considerations that you need to have in the back of your head when you are starting to use Azure DevOps environments? First of all, naming convention. You need to think about how you're going to name your Azure DevOps environments, and so that it is not only easy and understandable for you, but also for the others who may need to access those and use those as part of their everyday life. Also, you need to think about how you're going to group resources across different Azure DevOps environments so that you can avoid namespace conflicts, as we have seen, and also to have a more structured approach, a more cleaner approach for grouping of your resources, since ideally you would want to have an Azure DevOps environment represent a single location. Also, you should think about how you're going to reference an Azure DevOps environment with respective resources across multiple pipelines and pipeline stages. So in case you would need to change that, it may be wise to use variable groups so that you need to update this information in one place instead of going and hard coding it and updating it in every single pipeline and deployment stage. Also, you need to think about approvals and checks and what would make sense to add in order to add some more control to deployment to different environments, especially to staging and production. And as we have seen, there is quite a good list of different additional checks available in the approvals and checks section of an Azure DevOps environment page. And finally, you should think about how you are going to add it or migrate the resources across Azure DevOps environments in case you have some changes in your Kubernetes clusters. You can do this either through UI, which requires quite a few clicks and manual actions, or you could utilize Azure DevOps REST APIs for that to automate this process to make it faster and easier for you to perform the migration. And you are very much welcome to use the script I have created and customize it to your needs. Lastly, here are a few useful resources that I have prepared for you to investigate the topic even further, even deeper. I have a blog post series on my tech blog where I go in more detail into the different naming and grouping strategies and pros and cons of those. And also in part 2 of the blog post series, I also have a walkthrough with the demo, which is a bit simpler than the one. Bit smaller than the one we have done today. Also, here is the link to the script that we have used to migrate resources to a new Azure DevOps environment. And finally, I would like to recommend you also to check out the Microsoft docs and their Azure DevOps environments section. And I know that it may be hard to type in these URLs for manually, so I have prepared a QR code for you, which goes straight to the GitHub repo where this demo application and the relevant resources are available for you to use them and dig deeper into the topic. And if you have any questions, any comments, any feedback, I'd love to hear from you, so let's connect. You can check out my tech blog at christhecodingunicorn.com. I am open to connecting at LinkedIn, so please find me there. I'm also tweeting at christhecodingu1. It looks a bit like L, but it's actually a number 1, so you can also we can also connect there. And finally, I have all of my repos on GitHub at Guide Me to the Moon. That's it. We have reached the end of our session today. I hope you enjoyed it. I hope you found it useful and learned something for yourself that you can also take further with you into your projects, into your use cases. And thank you so much for tuning in. Enjoy the rest of Azure Back to School 2022, and I'll see you soon. Bye!